Hi everyone. So in this series of videos, I'm going to be talking about how to solve all the problems in Chemistry 11 Sample Exam 2, which is dealing with problems in aqueous chemistry as well as gases. So the first question here is going to be on the gas topic, and this one is asking you whether any of the plots shown here will represent the equations in the empirical gas law. So what we have to start with, of course, is what the empirical gas law or the ideal gas equation. That's just PV equals nRT. And what we have to show here is whether the variables have a inverse relationship or a direct relationship. And so to do that, I'm going to rewrite the equation as PV over NT equals R, because what that allows us to do is see all the variables on the left side and then the constant on the right side. And what we have to understand is mathematically, how do we relate two variables so that they will give us a constant on the right side. So the variables that have inverse relationship are variables where if one goes up, the other one has to come down in order to give us that constant value on the right side. So for example, P and V, right, would be an inversely related variables, because if P goes up, for example, V has to come down in order to give us a value of constant. So PV would be one, the other one would be NT. Now let's take a look at the variables that have a direct relationship, or variables where if one goes up, the other one also has to go up in order to give us a constant. So variables that have that relationship in this equation would be, say, P and N, right? So if P goes up, N has to go up to compensate to give us a constant. So P over N, and then V over T, P over T, and V over N. The reason this is important to first determine is because if you want to get straight line plots, then for the inverse relationship variables, you have to plot one variable versus the inverse of the other variable. So for example, if I want to get a straight line with P and V, I'm going to have to plot P versus 1 over V, or I have to plot V versus 1 over P. Whereas if I have the direct relationship variable, then I just need to plot one variable versus the other one directly. So for example, I can plot P versus N, and that will give me a straight line, or V versus T, and that would also give me a straight line. So now that we have those ideas understood, now we can look and analyze each of the plots that are given to us here. So the first one is a P versus T plot, and P and T, as you can see here, is a direct relationship, which means that you'll get a straight line if you just plot the P versus the T directly, which is what they're showing to us right here. So this one would be a plot that shows correctly the relationship in the ideal gas equation. Plot number 2 is a little bit more difficult, because what they're plotting is not one variable against the other one, but it's one variable V against the ratio of one variable with another one. So what we have to look at is first V and then V over N, and to see if there's some kind of relationship here. So V over N is directly related to each other. So what we have to think about, how would things look like if we were to plot V over N? So V over N, of course, is a constant based on the ideal gas equation. So that means that regardless of whatever value of volume I have, the ratio of volume to number of moles will always be a constant. So what the plot is showing us is a bunch of dots going up, which means the value of the y variable or the volume is changing, but then the V over N, the x variable, doesn't change. It all stays on that value. So that, of course, gives us the correct relationship that's observed in the ideal gas equation. V over N equals a constant. Now let's take a look at plot number 3. We're plotting V versus T. V versus T is another direct relationship. So if we plot V versus T, then we should see a straight line. Problem with this plot is the following. When you plot V versus T, the direct relationship tells us that if V increases, then T has to increase along with it to give us a constant, which means that the plot that we should see is something that looks like that, right? As one goes up, the other one also goes up along with us. What you see on this plot here is when V goes up, T actually goes down, and vice versa. So that's not really showing what we should expect out of the ideal gas equation. So this last one then is the wrong plot. So then the correct answer is only 1 and 2, which is answer A right here.